Okay, hey, to begin number 7, I want to start by looking at the original problem. So the original problem, you have that negative x minus 4 over 3x plus 2, x minus 2, divided by 5 times quantity x minus 4 over x minus 2, and 7y minus 5. Okay, so when we're dealing with this, notice that when you have the division, you have 4 different restrictions on the bottom, or 4 restrictions. 3 of them are different. Okay, because right now, if you make a 0 on the bottom, you're going to have undefined in one part or the other. Okay, so right here, you get an undefined of x cannot equal negative 2/3. Negative 2/3. Here, x cannot equal 2. Here, same thing. And then here, you have a y cannot equal 5/7. So whatever makes those zeros, remember you just set them equal to 0. Each quantity equal to 0. Okay? So for those of you that are struggling seeing that, I'm just assuming from our work with factoring, you know how to, you quickly add 5 to 7y equals 5, and then divide by 7. So y equals 5/7. Okay. Now, we have those restrictions, but then when we flip it, right, we don't divide the fractions, we multiply by the reciprocal, we pick up another restriction right here. X cannot equal 4. Okay, so we get one more restriction. Okay, so we'll list all of our restrictions at the very end there. Well, in this case, they're not asking us to simplify, but we're going to simplify. Okay, so cancel this, cancel that, cancel there, and cancel there. We end up with what on top?
7y minus 5.
Good. Good. All right. How about on the bottom?
Over 5 times quantity, 3x plus 2.
Good. Over 5 times quantity, 3x plus 2.
Or you can write as 15x plus 10.
Or you could write, yeah, you could distribute out. And x cannot be, then you have this whole list of stuff. X cannot be negative 2/3, 2, and 4.
And should we put the little McCoy number above the 2?
No, you don't have to put multiplicity.
Okay.
It's pretty cool though, I get it. Okay? And y cannot be 5/7. All right. That load right there. Any questions on that one? Okay. Do you have, it doesn't ask you to. I thought we'd follow through on it. Okay? Hey, this one, number 8. So we have our a squared plus 2a minus 15 all over a squared minus 16 divided by a plus 1 and 3a minus 2, or 12, excuse me. So before we begin doing anything with flipping the fraction, let's go ahead and simplify it, or excuse me, factor it first. So factoring it out, this becomes
A plus 4 and a minus 4.
okay. This becomes good 3 times a minus 4. Here, that's already set. How about this? A plus 5, a minus 3. Well done. All right. So we have that whole set there. I'm just going to go ahead and move that now. And that whole set there. And now, listing our restrictions. Might as well start a big set of restrictions here. A cannot equal, looks like plus minus 4. That takes care of all of our bottom right now. And then when we go to rewrite it, we're going to pick up one more. Remember, we don't flip the front fraction, just the back one. Okay.
Technically, it couldn't be flip either. Yeah, as long as you didn't flip both of
Well,
them.
since you're dividing
Hey,
by
flip
that,
your fraction around though.
Oh yeah, because you're dividing.
Yeah, you're dividing.
Oops, I missed one of my restrictions here. Oh, I'll just write another thing. You get your own little cool guy area there. Oh, and that's special. Okay. So, that's why I use pencil, then you can erase. Let's go ahead and cancel out here. You don't get to cancel tons.
Ooh, just minus 4.
Sheesh. All right. The numerator we get a plus 5, quantity, and quantity a minus 3. All times 3.
Alright, 3.
On the bottom we get a plus 4 times quantity, a plus 1. You can multiply them out if you want. You don't have to do that. It's nice if it's in factored form. What's that?
Would you recommend it?
No, I just leave it like that. Okay? So that's simplified version with our restrictions. Here we go. Even though it doesn't look too simple, but
It is.
I know.
It is in simplest.
Hey, remember, as we're going through this, I want you guys to recall 8, 1, 2, and 3, where we're graphing. Okay? Like if we were to multiply this out, you would have 3a squared on top, right? Everyone get that? A times a is a squared, and you get the 3. 3a squared on top, a squared on bottom. Where's your horizontal asymptote?
Oh, it's 1. No, wait.
Power's the same. It's at 3, yep. Okay? Our horizontal asymptote's at 3. Where are vertical asymptotes?
That would be
The ones we listed. Plus or minus 4, -1.
Yeah, we have a hole at -4, right? Right?
Oh yeah. 'cause we're
Removable discontinuity.
plus. And then, so it would be 4.
Or excuse me, a hole at, yeah, positive 4 and asymptote at -4 and -1. Just check that out in your calculator, see if that works out.
Oh yeah, negative. No,
Okay.
negative 4.
Hey, let's go ahead. Our assignment today, I'll give you that.